Imagine everything around you coming to a standstill. The birds in the sky freeze mid-flight, cars stop instantly. Even the air molecules lock in place. This is the captivating idea of time freezing, a concept often explored in science fiction. But could there be any truth behind this fantastical notion? Could the universe ever truly press pause? While our everyday experience suggests that time flows at a constant, unchangeable rate, modern physics paints a more nuanced picture. Let's delve into the fascinating world of physics to see if time freezing is merely a fantasy or a possibility hidden within the fabric of the cosmos. Our intuitive understanding of time is linear. It flows from the past through the present and into the future. Seconds tick by, minutes turn into hours, and days become years. This perception is so ingrained that we rarely question it. However, physics teaches us that time is not absolute. It is not a universal metronome ticking at the same rate for everyone everywhere. Instead, time is relative, its passage intertwined with motion and gravity. This mind-bending concept is at the heart of Einstein's theories of relativity. Einstein showed that time slows down for objects in motion relative to a stationary observer. This phenomenon, known as time dilation, becomes more pronounced as objects approach the speed of light. Similarly, gravity also warps time. Time flows slightly slower in stronger gravitational fields. These effects, while seemingly bizarre, have been experimentally confirmed. Einstein's theories provide the first hints that our everyday perception of time might be an oversimplification. If time's passage can be altered by motion and gravity, could it be manipulated in even more dramatic ways? Could we theoretically slow down time to a crawl or even bring it to a complete stop? Here, we enter the realm of speculation. While Einstein's theories allow for time dilation, they do not provide a mechanism for completely stopping time. To achieve a true time freeze, we would need to find a way to either completely stop the motion of every particle in the universe or create a region of space-time with infinitely strong gravity. The idea of time freezing has captivated the imaginations of storytellers for decades. Science fiction films and books often use this concept as a plot device, allowing characters to move freely through a frozen world or experience time at a different pace. One iconic example is the film Groundhog Day, where the protagonist relives the same day repeatedly. While the film never explains the mechanism behind the time loop, it highlights our fascination with manipulating time. Other films, like The Matrix and Inception, explore the idea of manipulating the perception of time, creating worlds where time seems to slow down or speed up. Section 5. Bending time in the lab. While completely freezing time remains firmly in the realm of science fiction, researchers are making progress in understanding and manipulating time at incredibly small scales. Experiments with atomic clocks, which are the most precise timekeeping devices ever created, have confirmed time dilation effects predicted by Einstein's theories. Scientists are also exploring the bizarre world of quantum mechanics, where particles can exist in multiple states simultaneously. Some theories suggest that manipulating quantum states could potentially allow for limited forms of time manipulation, such as reversing the flow of time for a single particle. Section 6. The unstoppable flow of time. Despite these intriguing avenues of research, it's important to remember that we are far from achieving time travel or time freezing as depicted in science fiction. The laws of physics, as we currently understand them, present formidable challenges. For example, even if we could somehow stop the motion of every particle in the universe, it's unclear how we would restart time without violating fundamental laws of physics. Furthermore, achieving a complete time freeze would likely require unimaginable amounts of energy, far beyond anything we can currently generate or harness. Section 7. The quantum realm, a different perspective. While the idea of completely freezing time might seem impossible within the framework of classical physics, the quantum realm offers some intriguing possibilities. In the quantum world, particles behave in ways that defy our everyday intuition. Time itself might behave differently at this scale. Some theoretical physicists have proposed that time might not be continuous, but rather quantized, meaning it exists in discrete units, much like energy levels in an atom. If this is true, it might be possible to manipulate these units of time, potentially allowing for limited forms of time travel or time manipulation. Section 8. Time travel and its paradoxes. The concept of time freezing is often linked to the idea of time travel. If we could freeze time, we could theoretically use that ability to travel into the future by simply waiting in a time-frozen state. However, time travel, even in its theoretical forms, presents a host of paradoxes. For instance, the famous grandfather paradox asks what would happen if a time traveler were to go back in time and prevent their own grandparents from meeting. If they succeeded, the time traveler would never have been born, creating a logical contradiction. These paradoxes suggest that there might be fundamental limitations on our ability to manipulate time in such drastic ways. Section 9. The enduring allure of time. The concept of time freezing continues to fascinate us, blurring the lines between science fiction and scientific possibility. While a complete time freeze might remain elusive, the relentless march of scientific progress continues to challenge our understanding of the universe and its mysteries. Perhaps in the future we will unlock even deeper secrets of time, revealing new and unimaginable ways to explore the cosmos. Until then, the enigmatic nature of time will continue to inspire both scientific inquiry and our boundless imaginations.